Hi all, welcome back to software engineering course. Let's get started. In the last class, we had studied about function oriented design, its examples, the structure charts and all, right. So today we'll discuss another type of designing, that is object oriented design. This is object oriented analysis and design, or just object oriented design. So here what will happen is, this is an approach for analyzing and designing your application or the system by applying object oriented programming. Okay, then why do we use this one? So this has many advantages, right? Your object oriented concept, we have many advantages over here. So this object oriented concept, or designing, it resembles or it closely represents the problem domain or the real world problem, so which makes it easier to produce and understand the design. So if you have a requirement change, and if you are using this object oriented designing and programming, right, what will happen is it is easier for you to change the objects, so that the requirements, whatever that there is a change in the requirement, you can implement it very easily. Okay, so first we'll look into the basic object oriented concepts, that are classes and objects, encapsulation, state, behavior and identity, relationship among the objects, inheritance and polymorphism. So these are the basic concepts in the object oriented programming. Okay, so after this we'll study about UML and other diagrams. So first thing, what is a class and its objects? So the classes and the objects are the building blocks of the object oriented design. Now it is an abstract and user defined data type. So it contains several variables and functions, right? So the objects are the entities that encapsulate some state, and it provides services to be used by the client. So it could be another object, program or a user. And your class is just the definition. Okay, it does not create any object and it won't create or hold any of the values. So whenever you create the instance or object of that particular class, then only the memory would be allocated for those objects. So your classes, it will have a interface. It defines which parts of an object of the class can be accessed from outside and how it can be accessed. A class body that implements the operations in the interface, that is your methods, instant variables that contain the state of an object of that class. So your class is just a blueprint. Okay, we can say that the implementation of the class is object. The class is not visible to the world, but the object is visible. Okay, so for example, say suppose you have a class called as class name is car. So the this class can have, say it has the variables car id, car color, engine number, then distance, then you have a methods or the functions called as distance traveled, petrol used, music player, display. Like this we can define a class. Next we'll see about the access modifiers. Okay, now these access modifiers are used to implement the one of the important concepts of object oriented programming, known as data hiding. Okay, so for data hiding we will use the access modifiers. So the access modifiers are public, protected and private. Okay, so these access modifiers or access specifiers in a class, they are used to assign the accessibility to the class members. That is, it sets some restrictions on the class members not to get directly accessed by the outside functions. So first we'll discuss about the public access specifier. So here what will happen is, all the class members that are declared under the public specifier will be available to everyone. Anyone can access this type of data, or objects or the data members. So the data members and the member functions that are declared as public can be accessed by other classes and other functions as well. The public members of the class can be accessed from anywhere in the programming using the direct access operators, that is dot, with the object of that class. Getting it? By default the members would be private. So if you want to make it public, you have to have this public name in front of your method or member. Okay, The next one is protected. So this protected access modifier, it is similar to your private access modifier in the sense that it can those members that are declared as protected, so it can't be accessed outside of its class unless with the help of another friend class. That is, the difference is that here the class members declared as protected can be accessed by any of the subclasses or derived classes of that particular class. So it is said protected, these are the declarations that are accessible from within the class itself and from its subclasses or the derived classes. The last one is private. So these are the declarations that are accessible only within the class itself. Right? Private, whatever, whenever you declare a member function or the member as private, then again, if you do not specify anything, by default it would be private. So in that case, only the class, within the class only you can access these members. Outside the class you cannot access them. Okay, now we have two other concept called as constructor and destructor. So what are these? So the constructor is it will have the same name as your class name, and its operation is for creating and initializing of the objects. The destructor, what it does is it destroys the objects. Okay, the next concept is encapsulation. So encapsulation, it means wrapping up of the data and information under a single unit. Okay, so the data and the information would be wrapped up in a well defined abstraction. The set of services that are requested from outside the object, it forms the interface of that particular object. So an object may have many operations defined only for internal use and that cannot be used from the outside. So basically what it does is like it will restrict the use of data and information. So the major advantage of encapsulation is that the encapsulated data is limited to the operations defined on the data. Next, we will study about state, behavior, and identity of the objects. So all the objects will have a state, behavior, and identity. So first, we'll look into the state of the object. The state or the attribute, these are all the built-in characteristics or properties of that particular object. Okay, so for example, if you consider a TV, so what is the state of that TV? So a TV has a size, a color, model, etc. Now this color, model, size, these are the state of that particular TV. Next is behavior of that object. The behavior or operations of the object are its predefined functions. Again, if you consider a TV, you can the TV can show you the picture, change channels, you can tune for a channel, you can volume up or volume down. So these are the behaviors of the object. So if you consider TV, so the changing of the volume, changing of the channel, this will become the behavior of that particular object. The last one is identity. So each object should be uniquely identifiable. So you can distinguish a object from one another. That is the identity. So for example, the fridge cannot become a TV or the other way around, right? It uniquely distinguishes the objects. The identity, it uniquely distinguishes the objects. Okay, the next one is relationship among the objects. So the relation between the object, it defines how the objects will interact or collaborate to perform any operation in that application. So whenever you have objects, they will have to communicate with each other, right? By sending the messages or by invoking, the functions. So this relationship, why this is needed is because to perform the operation in a application or in a system. So whenever your object it receives a message, the object it invokes the requested service or the method invoked. It will invoke the requested method, and if needed it would send the result back to that particular object which has invoked or which has requested for that particular message. So we have two parts here, one is client and other one is server. The client is an object, it will send the request to the server and and the server is an object that will provide service to its client. Okay, So if an object invokes some other services in other objects, so we can say that the two objects are related in some way to each other. They are having relationship between them. So there is this particular type of relation we call it as a association. Okay, and this association is also called as link. So other type of relationship could be the aggregation, inheritance, association, and composition. Okay, now let's see about the inheritance and polymorphism. So this inheritance, it means it is a relationship between your classes. Okay, so whenever you have this inheritance type of relationship, that means one class can inherit the properties of another class. So for example, if you consider two classes A and B, okay, so say suppose these are the two classes and we have a arrow something like this. Okay, that means B is inherited from class A. Now class A is called as the parent class or superclass or the base class. B is called as child class or subclass or derived class. This means class B has been inherited from class A. Okay. Now this B again has two parts. One is the derived part, another one is the incremental part. Now this derived part is the part that is inherited from A. The members or the functions that are which are present in A, those can be used in B. And the incremental part is that the new code or the definition that has been specifically written for this class B. Okay, so the inheritance, it comes into picture whenever there are minimum of two classes, and the subclass, it inherits the properties, that means the members and the functions from the base class. Okay, it is the same here. Inheritance is also called as is a relation, and the power of inheritance, it lies in the fact that the features of the subclass can be accumulated in the superclass. So again, this is a example here. Okay, so where this is a subclass and this is a superclass, so you have derived part and the incremental part here. Next we'll see about the polymorphism. So the word polymorphism, it means having many forms. So we define polymorphism as the ability of a message to be displayed in more than one form. Say for example, take a real life example of a man where he behaves differently in different situation, or the behavior of a man in different situation. For example, if he is in a home, he can be a father and a husband. If he is in a industry, he can be an employee. So the same person poses different behavior at different situations. So this is called as polymorphism. Again, we have two types of polymorphism: compile time polymorphism and runtime polymorphism. So this is enough for the concepts of OOPS. So the next thing is UML, that is Unified Modeling Language. So this UML, it is used for visualization of the design. That means it is a graphical notation for expressing our object oriented design. So whenever you want to create a design using this object oriented concept, so you make use of UMLs. Okay, so due to the ability of the UML to create different models, it has become an aid for understanding the system, designing a system, as well as the notation for representing the design. So there are n number of UML diagrams. So for example, you have sequence diagram, class diagram, collaboration diagrams, object diagrams, activity diagrams. So the list is more. Okay, so we'll consider a few of them in the discussion. The first one is the class diagram. So the class diagram, it represents the classes that will exist in the system, the association between them, relationship between them. Then we have the attributes, that means the members or the member functions, whatever the things are there, we will represent them. So how can you draw a class diagram then? So a class is represented as a rectangular box, and that rectangular box is divided into three areas. Okay, so class will be something like this. it is a rectangle. Okay, and it has to be divided into three parts. The first part here, it has the class name. It should contain the class name, and the class name, the first letter of the class name should be in the uppercase. Next, the middle portion. So this part, it contains the attributes or fields of that particular class members. Okay, and the attribute name, it should start from a lowercase. And if suppose you have two words coming into that attribute name, then the first letter should be the lowercase, then the second word's first letter should be capital. The last one, this part, it is used for writing the method names, and the methods at the end you have to represent this one, open and closing bracket. That means it represents it as a function or the operation. Okay, again the naming the naming convention is same as that of your attributes. The first letter should be lowercase, right? Okay, then if you have interface in if you want to represent interface, it should be represented here and with this keyword. Within angular brackets you should have the keyword as interface. Okay, and if your class method or whatever your class methods and attribute, they have some properties or the access specifiers. So the access specifiers can be represented like this. Suppose you have public, right? So you have to write public in between this open close brackets. Otherwise we have some special symbols for that. So this plus represents public, minus represents private, and this hash, it represents it is a protected. Okay, the basic example whatever we discussed in this slide, we can see it here, right? So in this diagram we have four classes: animal, duck, fish, zebra. So these are the four classes, and each class is represented in a rectangular box, and it is been divided into three parts. The first part, it contains the class name, and the naming convention is important here. The first letter should be capital. The middle portion, it contains the fields of that particular class. Age is one field and gender is another field. You have colon and you have the data type in front of them. So here plus, it indicates these are public. Then the last portion, it contains the methods or the functions of this particular class. That is memo. Okay. So here the first letter is small and the second word's first letter is capital. And whenever you have it is a function, you should have this open closing brackets. Again this plus, it represents it is a public. Then again we have three classes, right? So again it is same as that of whatever we have discussed here. The only change is here this one. The minus, it represents it is these two attributes, and this method is private. Okay, and this arrow mark you can see over here, right? So this represents the inheritance relationship. Remember, even we have different types of arrows. Those type of arrows would suggest or give the different meaning. So for association we use different type of arrow, generalization and specialization we use different type of arrow, inheritance we use different types of arrows, right? Okay, the next one, the relationship. Again they have used here the generalization and specialization relationship. So how can we represent them? So these are the arrows that come from your subclass to the superclass. You can see over here we have the arrows coming from the subclasses to a superclass, such that an empty triangle should be placed over here, and the top or the tip of that triangle should be connected to the superclass. Okay, now this is an example for a college, that is a IIT college. Okay, so there is a person in that college. He can be either a student or he can be an employee. Again the student can be undergraduate student or postgraduate student. Then we have employee. The employee can be either a staff, he can be a research faculty, or he can be a normal faculty. Okay, so we have multiple classes over here. So this is a base class, these two are inherited from this class, these two are inherited from the student class, and these three are inherited from the employee class. Okay, so whenever we have this generalization and specialization relationship, it is something, it is represented in this way. So the arrows coming from the subclasses, then you have a triangle, empty triangle, which is here, and the tip of that empty triangle should be connected to your base class. Okay, and there is one more relationship over here, that is the discriminator. So this specifies the job nature of this employee. Okay, he can either be either one of them, either faculty or staff or research faculty. Okay, so this discriminator, it says that the objects of the superclass type are partitioned into sets of the object of different subclass types. So this is one way of representing, or this relationship. We have again different types. Next one is association between the class. How can we represent association relationship? So it is shown by a line between two classes, and the association may have a name which can be specified by labeling the association line. So how can we represent a association is like this way. So this arrow you can see over here, right? So this is an association between two classes. So this comes into picture, this association relationship comes into a picture when we have two different classes. Then to relate them, we have the association. The next one is aggregation relationship. So this aggregation relationship is nothing but has a relationship. Okay. So if we consider this example, a person who is in a working or studying in a IIT, he has an address, he also has a biometric. So these two are not related, so but it belong to a same person, right? So we have the association relationship here, and this association relationship, it can be named like it can have multiplicity, like two addresses can be there for one person, biometric can be only one for this person. Then we have this aggregation relationship, a small diamond here, right, connecting the classes to this particular base class. So what does this represent is like, as aggregation is nothing but a has a relationship. That means a person has addresses and he has biometric. So we can represent aggregation something like this. Again, it can have the multiplicity over here. Okay. So this is how we represent the class diagram. So, how we have to represent a class diagram? The rectangle box, three paths there, then the naming convention, then we'll have to draw about the relationships. Okay, so we'll end the session today. From in the next class, we'll see about the sequence diagrams and all. Okay, thank you.